Okay, this video is going to hopefully be quite a straightforward demonstration of how you can use MPLAB X when you're programming in assembly to determine how long your code is going to take to execute. Then I'm going to go Window and go into Debugging, and then this is the really useful thing, Stopwatch. Now, Stopwatch is open here. I don't like it open there, so I'm just going to click that tab and I'm going to then park this panel over on the right hand side. Now, if you, depending on where you drop it, it could, occupy here, it can occupy up here. It depends where. And I think if you pull it over there like that, then you can actually occupy the whole of the right hand side, which you may or may not like. You'll actually see here that there's some things here. These previous outputs, in fact, I think this current one here, 17 microseconds, this is how long the code has actually been running so far. Now, let's ignore that one for the moment. In fact, what we can do, we can either clear the history, so that will completely clear it, or we could just reset or clear the stopwatch now. So if I clear the stopwatch now, I will be resetting the stopwatch to 0. So let's just do that. So the stopwatch is now cleared and it's set to 0. So if I then press F7, which will execute just this current line, which I'm going to do now. So now on the next line, you'll see that the instruction just executed took 1 microsecond, 1 instruction cycle. Remember, that's not the internal oscillator, not 1 cycle of the internal oscillator. That would actually be 4 cycles of the internal oscillator, which is 1 instruction cycle. So then if I were then to press F7 again, so now we've got 2 instruction cycles, because remember we executed this line, or that instruction really. We then executed that instruction, so that's 2 instructions, each one takes 1 instruction cycle each. So now we've taken 2 microseconds so far, or 2 instruction cycles. Now the go-to instruction, which is about to be executed, if you check the data sheet, you'll find that a go-to command actually takes 2 instruction cycles. So if I now press F7, and sure enough, now we've executed the code, taking up 4 instruction cycles, which is 4 microseconds. And so you can carry on, and you could have I just repeatedly pressed F7 now. So let's just stop the debugger this time, and let's have a breakpoint somewhere else. So this time around, I'm going to add the breakpoint there, and we can run the code. You've probably got the idea already, but how to use this. But anyway, let's see. So yeah, so what have we got so far? We've got a cycle count of 2. Okay, so 2 microseconds. So what has actually taken 2 microseconds? Well, when you think about it, the code that's executed so far, remember, that's not executable code. That's stuff that the linker or the assembler will be using. But this is the only code that's executed so far, a go-to instruction, and that's taken 2 microseconds to jump to this. Okay. So then if I then press F7, now remember, if I press F7, it's actually going to do this, execute this call. So that's going to be 2 instructions, because this goto, which is what we call an unconditional branch, that takes 2 instruction cycles, and so does the call. And so now you see, yep, so 2 more instruction cycles, so now taken 4 instruction cycles. Now, bank cell is a directive, it's not an instruction. So it might not be clear to you exactly how many instruction cycles that's going to take. It used 2 instruction cycles. Now, if you weren't sure about what bank cell actually did, because remember, it is a directive, it's an assembler directive, so the assembler directive will be interpreted and made into machine code. So if you're not sure what that does, we can find that. So let's have a look. So we go Window, target memory views, I think, and program memory. And you'll actually see, you see it says init, that's the label there. Well, let's get that window back. Where did it go? It's gone somewhere, hasn't it? Oh, there we go, program memory there. Okay, so you'll actually see that at the init label, there's actually 2 commands, bitset file status and 5, and bit clear file status 6. So those are setting the RP0 bit, and then that's the clearing the RP1 bit. So yeah, sure enough, these two instructions actually took. That's why it took 2 more instruction cycles. So we're currently at a move a literal into the working file register. So that's only going to take 1 instruction cycle. So let's prove that. So yeah, we're now on to 7 instruction cycles, and I'll just keep on pressing F7 again. So thanks. So that's going to take 2 more. We're currently on 8, but when we execute this, it will presumably it's going to be 10, and it is. And then clear F, that's going to take 1 more instruction cycle. So we're now on 11. You get the idea, okay? Return, that's I think would use 2 instruction cycles, and sure enough it did. So hopefully you've got a clear idea on how this works. Now, one thing that I should point out is that the instruction cycles is going to be accurate, but the actual timing may not necessarily be accurate. If, say, for example, we were to change the OSCON register, and so I were to do this, and this, I believe, is going to set our internal oscillator to, I think it is something about 32 kilohertz. I'm just thinking it might be 31.25 kilohertz, but I'm not sure. But anyway, it's a much lower frequency. And if we were then to run this code again, so I'm just running it now, and you'll notice it still says that the command that's executed so far, which is the goto, took 2 instruction cycles, correct, but it still maintains that it's 2 microseconds, which clearly can't be right if we have reduced the speed of the internal oscillator so much. So sure enough, it still thinks that 1 instruction cycle is going to be equal to 1 microsecond. So something appears to be going wrong. It's actually not, but I'll show you where we can fix this. First of all, before I forget, I'm just going to change that back to the configuration for the 4 MHz oscillator. So the thing to be aware of, the stopwatch doesn't take account of the oscillator speed that you might set in your code. So the stopwatch uses the simulator option settings, and that's for the project. So I'm going to go over here and click this project properties option here, and then you'll see somewhere around here, there we go, simulator, and then it says instruction frequency, the frequency of the instruction cycle. So you'll see there that is set to 1 megahertz, which is basically what we're doing here, because we're setting the internal oscillator to 4 megahertz, and that's going to be divided by 4, which gives us 1 megahertz. So just be aware that what we have here is what the simulator is going to use, and if we programmatically set a different frequency, that's going to be ignored by the stopwatch. So if, for example, I were to change this now to, let's just delete that, 0.5, so we have now halved the frequency of the instruction frequency, and then if I would then click that, OK, and now run, and you'll notice this time around it says, well, we used 2 instruction cycles, but it actually took 4 microseconds. Let's just clear this window, and now you'll see each time I press F7, you'll see that it fully takes into account that we've got a slower, or we've configured the simulator to have a slower internal oscillator. So in this case, 8 instruction cycles would take 16 microseconds. So bear in mind that if you configure your oscillator in code to do this, sure enough, that's actually going to work when it comes, or hopefully that's going to work when it comes to loading it onto your microcontroller, the real world microcontroller. But the frequency that the stopwatch uses is not this, it is using the simulation settings here. Okay, so that's the one. Now, by the way, I can't change this at the moment. Presumably it says unlock. I think the reason for this is because I'm currently running a debug session, so I've never tried clicking unlock. What I'm going to do, I'm just going to stop there, and then I'll click configure, and then I can go simulator, and notice now it's not locked. So I can change that like so. Yeah, in fact, you don't need to click apply. You can just click on OK. And now when I run, you'll see we're back to normal, 2 cycles, 2 microseconds, just like that.